Welcome into the stream. We're going to be talking about some ModBus stuff today, and it's going to be fun. It's going to be cool. Had a little bit of a hiccup. I'm going to edit all of that other stuff out of my camera crapping out and like all of that stuff. So, yeah, going to get all of that straightened out, and we're going to get into talking about ModBus, talking about ModBusTCP. We're going to be going through and setting up a server on a 1500 TCPU, and then setting up a client on a 1200 PLC, and then getting them talking back together. Before we get started, I do want to kind of go through all of the stuff as everybody's kind of coming back and getting settled in, hopefully this Friday, over in kind of Eastern Europe. Hopefully you've gotten home from work, you're sitting down and sitting back for a cup of your warm drink or whatever, and ready to sit and learn some TIA portal topics today. Had a little bit of fun in the kind of the thumbnail. If you didn't know, I'm an absolute nerd, and if it's proven, if that was ever in question, it should be proven, because in my thumbnail, that's actually me, and you could see that's my weekday outfit, you know, like going to work, and when you work for Siemens. Ignatius, it'd be awesome if Hagemerl would join in the stream. It would be pretty cool. Oh, I've got to do a couple things, because Ignatius and my how do I do this? We're going to do that, and then we're going to. Is that going to do that? Is that going to let me? I don't know. Did it let me? Oh, hold up. Hold on. I want to see something, because Ignatius, you have done standard there, and then Lucid is also in here, and they are kind of my number one people here, and so they're going to help out. They're going to be able to kind of. Because you're mentioning Hagemerl. Hagemerl is back. He has like a real live stream, and he has like a real chat, and he like streams, and he has a lot of people going back and forth. And what we're trying to do in those communities is develop an automation community. It's one of because most of us are nerds. Most of us are kind of have our interests that are kind of evolved around automation and doing cool stuff with stuff like that. And so it's cool to have a community that seems to be growing, and Hagemerl is doing an amazing job of kind of bringing everybody together, and hopefully we can do that as well here. So yeah, one of the things I wanted to say before we get started is thank you so much for all the members. If you are just coming in and you've never been a part of one of these streams before, we do have memberships here, and there's a couple of different levels. You see Mika in the chat. If you see that, like, he's got that orange star, that means he's been a member since day one of having memberships. And so it's been over a year that he's been here. And as you come in, the members get a couple of different levels. Eventually, these live streams, I'm going to go ahead and tell you, once I get the capacity to be able to edit them out and clip out all the videos, the live streams aren't going to be fully available after. You're only going to be able to catch the full VOD or the full live stream if you were there live, or if you were a member. Members will always have access to all of the VODs and everything. Currently, all of the live streams and everything are always available, and those that are available will always be available. But in the future, I'm going to try to get a little bit more organized, and like the thing about it is, like, YouTube loves like videos that don't really like the live streams. And so I've noticed the more videos that you could do and put out there, the more this information gets out. So eventually the memberships will kind of be, if you don't catch the live stream live, the memberships will be the way that you can view those on demand. But no fear. I don't have the bandwidth to be able to clip those videos up right now, so I'm not taking anything away from y'all. And we actually have our most recent member here that with this blue star. I think this is probably the first first person to join in chat, because technically he joined in chat because he came in, and I'm assuming they came in and joined in chat. So thank you so much for all the members, whether or not you're like Mika that's been around here from day one, or this is your first time. Welcome in. We're going to be getting going here soon, talking about ModBus TCP and stuff like that. But also, you don't have to join. You don't have to be a member to really support this. If you like and subscribe, that actually tells the YouTube algorithm, look at this. All right, the GOAT is in the chat, everyone. Oh, by the way, Hegemerl, you only missed like the total most authentic real thing ever. My camera not connecting and it having this weird, like me in a weird face. So it's great. All of that's going to be edited out. So everyone, welcome the GOAT of live streaming into the chat. We have we have automation royalty here. So it's an honor to have Hegemerl in here. It is great to see everybody. We're going to be talking about some ModBus and a little bit of an homage to Hegemerl. I have a lot of experience with PLCs, but my expertise is in drives. And so today we're talking about PLC topics. So there's going to be a lot of opportunity for things that maybe I don't quite fully understand, that you can join in and in chat, drop in and like kind of be like, hey, I'm not doing this right. There's an easier way to do this. You could do that like perfectly yeah, it's great. So without too much more, let's jump in and let's get started with the kind of talking about this ModBus TCP. If you're just starting in with automation, you've probably never heard of ModBus, or maybe that's the only thing you've ever heard of. And ModBus is a way for different devices to communicate to each other. If you've been around automation for a long time, you might be familiar with ModBus RTU, but that is the RTU portion of it is really just how the hardware that it's communicating over. ModBus TCP uses TCP communication, so TCP IP. It is kind of going over Ethernet. ModBus RTU is a serial interface, so similar but not the same to Profibus or DeviceNet, those sorts of serial communications. It was a hardware. So that's the difference between RTU versus TCP. On the back end, so like the registers that we're going to be talking about, that ModBus is kind of all the same. It sets up, it kind of goes through and does all that. So if this is the first time that you're hearing about ModBus, cool. We're going to all learn some stuff together, because ModBus has been around for ages, and it is kind of this standard that works for everybody. If you were using all Siemens processors and all Siemens technology, there are better ways of communicating back and forth. And I'm sure Hegemerl, there's a ton of content on his channel that kind of goes through and talks about all of that stuff. And same thing with Allen Bradley. There's probably, if you're all in Allen Bradley or Omron or Schneider or any of Mitsubishi, if you're in any of all of like kind of all together, then there's probably better and quicker ways to communicate. But if you're going between different manufacturers, if you're trying to communicate to, if you have a Siemens PLC and you're trying to communicate to an Allen Bradley PLC, ModBus is one of the better ways of communicating. Probably two ways that's the only way of communicating between those. So don't worry about like if you've been in Siemens and you've never heard of ModBus. There's a lot of different ways that you probably have this kind of like inter-device communication. So don't worry about that. Yeah, and like Hegemerl saying, ModBus is kind of the only one that I would say that is probably better or more commonly used now would be OPC UA. And the reason that these two, OPC UA and ModBus, are used so much is because they are they're not device specific. Like you can have the first kind of module that I used this ModBus Client for was what was the name of it? It's like Control by Web. It's like these little I/O modules that like someone had just put out in a piece in a device. It's super cheap. It's got ModBus TCP built into it, and I used this ModBus Client to reach out and communicate with that. That wasn't even a PLC system. So some of y'all that are familiar with my company, Alpha Industrial Technologies, knows that I'm not the only one. I've got Brandon Hughes, who is a ignition wizard, and he's kind of like a Python expert, whereas I'm kind of over here working with Siemens hardware and stuff. He actually used a ModBus Python package to communicate to these devices. So ModBus TCP is this ModBus kind of way that you could communicate back and forth between devices, and it's not necessarily even PLCs. You could do Arduinos, Pythons, Raspberry Pis. You could do just software, so like on your computer, because yeah, it's TCP. You don't have to have a serial port. So that's what we're going to be doing today. So we're just looking in, and yeah, if you're coming in and this is your first time in the chat, I will be talking about the ModBus stuff. We're going to go over that project. If you have a question about something else that's kind of off topic, feel free to ask it. And at the end, there's going to be kind of like a bonus time to where I just answer random questions. But I have like pretty bad ADD, and if I get off topic, then it doesn't really serve anybody well. But if you have a question about what I'm talking about, feel free to drop it in chat. I'll see it. I'll kind of get to a good point where I can answer it, because that's why we're doing this. We're trying to build a community. We're trying to help you guys out to be able to grow in automation and kind of go and be able to do all the things that are really going to be able to help you, your community, the company you work for. So we're here for you. But just know that if you're asking about some drive stuff, which if we have time, I've got about an hour that I can spend. Is that right? No, I've got 2 hours because it's 11:45 here. I've got a call at a meeting I've got to be on at 1:30. So got about 2 hours to work with here. There should be plenty of time because we're going to be able to knock out this ModBus stuff. So let's go into and just open up our portal. And so, as you can see, I have cheated. I'm not nearly as brave as Hegemerl is. I go through and I set up my projects ahead of time, and we'll talk about what's in this project. But as you may or may not know, as members in the second tier, you're going to have access to this project. So whatever we do here, the members at the programmer tier, which I think is like $5 a month or something like that, will actually get access to this project, and that'll be available to you for your archive, and you can move it up to whatever version of Portal you're in. I'm doing this in 17, and so you'll have access to this actual project. So what I've done is we have a couple of devices, and one of the things about it is I'll show you guys that I actually have these guys sitting back here. So I have this 1500T CPU sitting back on my workbench back behind me, and I also have a 1200 CPU sitting there as well. So when we're kind of going through this sort of stuff, this is going to be on real hardware. We're going to be actually going through and showing some of the problems that you might see with these blocks and be talking about them. But you can see I've got this 1515T CPU. This block, both of the blocks that are available for both the 1200 and the 1500. You don't have to have the T, you don't have to have the 1500. They are available, and you can run this ModBus server and client on either one. I set it up this way just because I had my 1500 already set up from the last, maybe it wasn't the last stream, but like 2 streams ago, we did a heart module. So there's a level sensor back there that we're going to be playing with that has some real data that's going to be coming in, and that's already hooked up. That's the only reason why I put the server on the 1500. So we're going to talk about the 1500 side of this first, the server side of it. And nope. And you can see I named my PLCs properly, but I'm not paying attention to them. So we're going to go in and ignore this. This is obviously the not Modbus stuff. So this is extra stuff that has to do with the level sensor and stuff like that. So what we're going to be talking about is this, not this, not that, this. We're going to be talking about the block MB server. First thing I want to show you is that this is available in our functions. And so if you come over here and in this search over here, like above my head right there, if you type in MB_server, it will, if my head wasn't in the way, whoop, wrong one, this, you can see that over here to right here, it pulls up your server. So that's, if you don't know where a block is, you could just use this thing up here, this search tool, and it will show you where that block is. So no, I want to move. Man, today, chat, like my presentation is just not good. It's like I've never done this before. I'm nervous, chat. But anyway, so that's where you find the ModBus server. And remember, one thing about the servers, you're probably thinking, okay, I would only ever want to run a one instance of this ModBus server. And you're probably right, but one thing that is different of the way that Siemens implements its ModBus server is that it only allows one connection per server. And we'll kind of talk about why that is. And I mean, so like Allen Bradley's, for example, it will allow multiple ones. And there's benefits and detriments to both of them, because one, and I believe, and Hegermerl may be able to correct me on this because I think he has a lot more closer connection to Siemens than I do. I was just a Siemens application engineer for a distributor in the US. And if you're not familiar with the way that Siemens US, the Siemens USA and Siemens AG work, Siemens US is kind of like a distributor for Siemens AG. And so if you're from Germany, if you're in Europe, you have a little bit closer access to Siemens, particularly, like you can communicate directly to Siemens people. Whereas in the US, you're actually communicating to a distributor, and then they are communicating to Siemens USA, and then maybe they're talking back to someone at headquarters. So there might be a little bit more of a reason why, in my opinion, it's a safety and security thing. Because if you have an open, and the way that this block is set up, if you have an open connection, it just will accept anything from any connection coming in. And then it kind of locks out everything else. And I'll talk about this when we were kind of setting up the block a little bit more, but I'm pretty sure it's a security thing, because there's some of the things of this server that you don't have to have. Like you have to set up, I'll talk about it here in a second. So you bring in the ModBus server block, and there's not a lot to it. You have this disconnect parameter, you have the holding registers, and then a connect parameter. And the disconnect is kind of exactly what you would think it is. If you want to disconnect communication from this, then you're going to be using that disconnect. So let's just go ahead and break everything by going on the line with both PLCs at the same time. Ignatius, yeah, the ModBus, using ModBus in servers drives communication, like it's pretty good because it is quick, it is fast, and you can set it up to be yeah, to be able to work very, very quickly. There might be some other people that know kind of like comparatively between uh, like Profibus, Profinet communication, like some of the speeds across that. I know that Profinet has kind of like a shortcut in the TCP stack, which is why Profinet is so much faster. That's why there's three versions of Profinet. There's just the Profinet, there's Profinet RT, which is real time, and then Profinet IRT, which is isochronous real time. And Profinet RT uses kind of this shortcut that Modbus TCP doesn't exactly have access to. And it's a little bit technical, but there's kind of a bypass in the TCP stack that's a little beyond what this is. So I would expect Profinet to be a lot quicker than Modbus TCP. But if you're doing just standard TCP communication, it's going to be basically the same. So especially for non-synchronous motion applications, this is going to be perfectly fine. You're going to be able to get down into that like less than 10 millisecond update time, and it'll be fine. Yeah. Yeah, Hegemerl's bringing up like RT. RT is guaranteeing the speed, whereas just regular standard stuff, like even if you're updating it, like in the block that we're going to be updating the client on, I will be running on 100 milliseconds. Unless you're doing something really crazy, 50 milliseconds, 10 milliseconds on some sort of like process, it's probably okay. Unless you're doing some sort of like tight control on something, 100 milliseconds is faster than most actuators, like inexpensive actuators can even work. So like it doesn't really matter. So yeah, who cares? So on this server, I will want to see. So let's bring the glasses up on here, and if you notice, this disconnect parameter is off right now. So if I go through and turn this on, and that is going to disconnect this server. So communication has stopped with this high. So by default, this block will start running. So technically you don't have to have that disconnect have some sort of parameter or input onto it. Well, actually, I guess you do, because it's an input. You need something there, because otherwise it won't compile. It'll complain because there's nothing there. But you don't actually have to toggle that on and off. And this kind of goes back to kind of the thought that I was saying about the reason why Siemens, some of the decisions that they make is a security issue. If you don't want people communicating, and because Modbus is bidirectional, it's not just read. You can absolutely write parameters. And so if you have an open door for someone to come into your house and like change settings on your Wi-Fi router, like of course you could probably see the security issues in that. And Modbus with an open port and an open listening connection, it's not doing any sort of like certificate connections like back and forth. It's not verifying. There's no lock, there's no key, there's no security. So if you just allow unlimited connections in, then someone would have the ability to come in and say, oh, I want to access this Modbus server. Even though you as the programmer have configured all of the connections that you want to, if you allow multiple Modbus connections, then you have the ability to say, oh, just an anonymous Modbus connection comes in and starts modifying data. I don't like that. Some other manufacturers that shall not be named, they don't see a problem with that, because they have multiple versions of this sort of stuff that goes about like that. So yeah, to each their own. I will say connecting up to a server that has multiple connections is a lot easier. So that might be the way. If you can choose security over ease of access, an unlocked door is easier to get into than a locked door. So that's that. So let's talk about what the rest of these parameters are. You have this MB holding registers, and I'm going to maybe pull this up if I have it over here. Sorry, I'm looking at my overly sized screen that I bought for a trade show that I use as my third monitor. Yeah, so what I was going to do is talk about the registers, because Modbus is split up into what are called registers. And if you are new to automation and you kind of are unfamiliar with how kind of data is broken up into words, and you have words are 2 bytes or 16 bits, that's a Modbus register. And in a Modbus register, it is just a word. And if you're familiar with like data types, like a real data type or an int data type, kind of like whether or not a Boolean is 1 bit, a byte is 8 bits, a word is 16 bits, a double word is 32 bits, and then a real is kind of like a decimal number. Those are going to be 2 words. It's going to take up 2 registers to get an actual real value. Well, Modbus doesn't inherently tell you what it is. It's just registers. So there's a little bit of stuff that we'll play around with after talking about this, but what you have to do is you have to set up that memory area. And sounds scary, sounds crazy if you've never done it before, but it's just a data block. So I'm going to go in and I'm going to show you my data block that I have made for this block. And we're going to not talk about this top part yet. I will in a second. But what you have is your Modbus registers. And if you notice, I have 16 words here, or 16 integers here. I have named them as integers just to make things a little easier to understand. You can create real registers, but just know that it's going to make the client side, which we're going to talk about, a little bit more difficult. We'll play around with those here in a second. But just right now, what I've created is you need an array of your registers. You don't necessarily have to have an array, but it just was easy to set up this way. One thing to note, if you are a Siemens guru, you probably noticed that this block is not optimized. And if you're new to Siemens, you have no idea what I'm talking about, and that's okay. But just know that this block is set up specifically so that you have these offsets here. In a regular data block that is optimized, you do not have these offsets. So what you have to do if you create a data block, you have to come into properties and uncheck this optimize block access button. So it has to be unchecked. And here is why. Because this block technically is using pointers. So these registers, and I know pointers are scary. Anybody that's here that pointers have traumatized you in your automation career, it's okay. TIA Portal handles them, and they're here for you. And we've got the whole community in here today. It's awesome. Logical Controls. If y'all hadn't checked him out on TikTok, he's got some great stuff out on TikTok. I don't know anybody else on TikTok that's doing automation stuff. I'm also not on TikTok, but Hegerbro is bringing up a very good point. A thing about the optimized data blocks. If you don't optimize them, then how do I put it in a not dull way? Your program, your memory is not as efficient. Like, again, if you're new to PLC programming and you're new to kind of the embedded programming world, memory does it just doesn't exist. If you've only ever programmed in Python or Java or C# or something like that, then you have no idea about memory allocation because you have a garbage collector and it just takes care of all of that for you. Well, if you don't use a if you don't use an optimized block, you don't actually necessarily get all of your memory. And it sounds kind of weird, but just know that with an optimized block in Hegemold, I would love to hear your explanation on what's actually going on behind the scenes with optimization, like in those blocks, because that's one thing that I know that it is basically using memory wherever it needs to. But that would be one thing that I would love to hear you kind of talk about on one of your streams about what's going on with the block optimization, other than just the fact that when you turn off block optimization, you take up a continuous block of memory. And then the reason that is so that you can do what's called an offset. And I've talked about in some other streams about pointers and data and stuff like that, and it's super nerdy and there's hours of it out there. But a pointer essentially is if you have a block of data like this register or these ModBus registers, a pointer just says, hey, go to this memory address, and then you can do whatever you want after that. It's just saying start here. It's kind of like on like a roadmap, or like you are here, and that's what a pointer. It's pointing to a memory location, and then this block, you'll see in the client side when we talk about it later, it's going to say, all right, I want to pull the next 5 words. 1, 2, 3, 4, 5. Okay, and then it goes, and you get those 5 words, or 5 words. You can't do that in an optimized block, because when you point to that memory location, you aren't guaranteed the next thing in this data block is not guaranteed to be in this next to it. So you can't just increment. And this is going back to on Hegemerl's stream. I was kind of crying about the loss of STL, because you can literally in STL just go through memory by indexing through memory locations, and so you can. It's like inherently tied into the hardware itself. It's so, yeah, it's well beyond what you need to know in order to use this block. Just know that in Siemens, you need to uncheck that box and do unoptimized blocks. Yeah, so logical controls. One thing that I've found out from logical controls, on his channel, he's an expert in the Mitsubishi ecosystem, and so they probably use a lot more of ModBus. And yes, the ModBus setup in the Siemens world is a little bit, especially if you're not used to working with Siemens, it can be a little bit like, why are we having to do this? So let's go back and let's talk about this last thing in here. So your mod registers, if you notice how I've done this, I have gone in and set up a block. If I wanted to set up a new block, new mod data, like this. And I want a data block, global, cool. If I wanted to set this up, if you notice in my data block, I had an address parameter and then my my registers. That address parameter, okay, so Larry brings up a great thing about the unoptimized block, is if you don't have to reinitialize the block if you download it. And there are some ways, and correct me if I'm wrong, there are some ways also, like with an unoptimized block, as long as you aren't making a structural change to the block, you shouldn't have to reinitialize it. But now that I'm saying that, that is the old S7 way. I think TIA Portal, even if you change just like a comment or like a name on it, as long as it makes you reinitialize it. So that might be good thing to bring up, Larry. We might test that. But as we're kind of like digging into this block, if you notice in my other block, I had this address parameter, and if we take a look at this connect parameter, if we hover over this, it says, okay, it's an in out, but what it is looking for is the start of what is called an IPv4 address. And you're like, where in the world where am I getting all of this from? Let's click on the block, click F1, and let the computer crash. I'm joking, but all of this information that I'm getting is in the help file. Siemens does a pretty good job on these blocks of doing the help file. And so if we look at this help file, this connect parameter is wanting one of these types. So a pointer, scary word, to the structure. The following structures can be used: a TCON IPv4, TCON configured, all of these things. I'll show you. It's looking for an IP address and a connection parameter. And so let's look at the way this is set up. If we open this IPv4, this TCON IPv4, it has interface ID, connection type, active connection, remote address, all of that. Where in the world? How do we bring that into our project? If you're starting from scratch, and this is kind of going back to one of the things that Logical Controls was talking about, if you never worked with PLC data types in a data block, then you're like, huh? What? I thought that was where you put integer or UDT or struct. Well, this is a built-in data type called TCON IPv4. And if you just go in here and say my connection and type in TCON IPv4, is that right? Yeah. It knows it's there. See? So if you go to this help file and it says it's looking for this TCON IPv4, if you just take and cut that and paste it into your data type over here, it imports that. Even if you've never used that in your project, it's built into Portal. It knows what it is. It's there. It won't start populating it like it did with me. It'll only populate, kind of use that little context pop-up when you have started to, or when you have already brought one into the project. So that's why it was popping up there when I was typing it out. But just know that, like, so for example, I don't think I have, so there's a data type called an IPv4. If you notice, my context menu is not popping up here, but if I continue to type this out and just hit enter, it says, oh, I know that because it's a built-in system data type and it has what that's supposed to be there. So, so what was it? TCON IPv4, that. So that is your connection. And this is kind of the part to where on the server side, a lot of this stuff doesn't quite make sense, but the two things that you really need to, that you're going to have to define is, on it, you have a bunch of like remote port, local ports, things like that. But if you notice on mine, I think maybe they're not. So 0 and 502. So the remote port, you're a 0 on these values is going to be, I'm going to allow any port coming in. My local port is, I am looking at only at port 502, which that is the ModBus port for ModBusTCP. And so we need to set that up there. and again, you have to kind of set this stuff up. The most important thing on this interface ID, in this that will absolutely trip you up, is the interface ID and the connection ID. So let me show you where to get that information. So in our device and networks, our setup, this 1500 processor has two network interface cards. It has Profinet 1 and Profinet 2. They're totally separate cards, so you can have totally separate IP addresses. So if I click up here on this little eyeball, it shows the IP addresses of this. And you notice two totally different subnets between these interfaces. Well, I am connected into this Profinet IE1, and that's what my laptop's connected up onto. That's what all this connection is. And so I need to identify what that connection is. And inside of TIA Portal, all of your hardware has these hardware IDs. And that's how you can bring in and kind of parse out information just based on a number. There's a couple of different ways to go through this. So I have highlighted the actual port, and you notice that Profinet has come up. If I go to Properties, System Constants, it will show me those Profinet interfaces, and it will show me those IDs. So if you notice here, there are three different hardware identifiers right here. Make sure I'm not covering anything up, but there's three different numbers here. If you notice, there's 64, 65, 66, and not all of them would work. The way that I physically have this connected up, I don't know which port, if it's in port 1 or port 2. I just know that it is on this 64 interface. And I know that I'm going to connect anything that's going to be connecting is going to be coming over that, in my case, that 172.24 network. If I wanted to go and connect this port, I would to something that was on, say, my IT network on this 192.168 network, I would have to use this 72 IP address, or not IP address, this 72 hardware identifier. So logical controls, that's exactly what you were talking about with the difficulty in setting these things up, because this is a Siemens thing, and these hardware IDs are just identifying the network paths that are involved. If you've ever worked with SIP communication in like an Allen Bradley processor, that network path that you have to kind of like parse out, you have to go like from your Ethernet card to the backplane over into the processor. And so those are all those kind of hardware addresses, and that's SIP. It's not this, but it's kind of the same thought process of what you kind of have to do in Allen Bradley. That is the extent of my Allen Bradley knowledge. Don't ask me anymore. Joking, but not joking. So another way that we can actually go in and do this is the context menu. So this is if you look at this hardware ID, we can start typing this Profinet. So like if we look back at our device and networks, this name here, so this local Profinet interface. So if we start typing local in here, it should come up with a context. Of course, it's not. But you can take this here and use it in here, and it will work, because these are system constants. So a constant, this is the tag name, this is the actual value. And so that's what a constant is. And these are system constants. And I don't know why the little context menu didn't pull up. It maybe because I'm online. Let's try this. Let's see if going offline helps us out. I don't know why it's not doing that. That's so weird. Anybody in chat knows why the context menu doesn't work on that? I don't know. But anyway, that works. And so let's see. This local. I don't know. It's a great mystery. It used to work. I don't know why. But it is that interface. So if we go to that is what that hardware ID is. And that hardware ID is very useful in a lot of different things too. So if that's the first time you've ever seen it, if you want to step your game up into Siemens, then that is going to be definitely the way that you are going to do it. Is that's going to be needed in a lot of different places. So that's where you find your hardware IDs for your components. By the way, like all hardware has a hardware ID. So like if you look at me clicking on this stuff, I'm getting these hardware IDs for everything in this system. So this module here, it has a hardware ID. And again, that's probably like I would say like a tier 2.8 out of 3 of difficulty in like what you're having to work with in that sort of stuff. But again, understanding what a hardware ID is, it's just a number that identifies the hardware. And in this case, it identifies the connection that we're going to allow this communication across. This second ID is the actual S7 communication ID. And this, again, going back, if you've never done Siemens, this is just weird. And it is here. You can find this stuff in the network view. If we were to go, and by default, this one's going to be 0. But if you can, where I have actually configured this the way I've gotten to this is I've gone to my network ID. I have clicked on the PLC, and I think it might just be on it. I don't have to have it highlighted. Yeah, so, and you go to connections, and you will see I have, for example, this local ID is 1. So they start at 1, and I'll show you because I've actually configured this device. It's gonna be on 1. If you don't have any other like of these Modbus, it's gonna be 1. If you don't have any of these kind of like separate connections, it's going to be 1. And so this will be what causes you to get tripped up on these things, is because not only do you have to have the hardware configured correctly, you have to have inside of Siemens, you have to have kind of this connection dynamic made properly. And so if we scroll this over, it should be programmed open user communication, and that is this block, because it's using inside of this Modbus block, it's using a block called tcon, and that is the kind of, or TCPcon, or tcon, no, it is tcon, whatever, whichever one it is. That's the way that Siemens communicates to all of this stuff, is with that internal block. And it makes one of these connections. And so if you don't have one of these connections, then it doesn't have a way to actually get into the program, essentially. And I'm sure that like Hegemer would be able to explain that so much better than I can, because again, I'm the weird drives guy. I'm talking about the PLC stuff. And so yeah. Oh, that's awesome. So yeah, so we've got a contributor to TIA Portal. So like actually coding TIA Portal. So awesome. Thank you. So yeah, maybe he can explain in chat. Maybe he can explain in chat a little bit more about what exactly that open user communication is, if it's anything else onto it. But yeah, so that is what that block is. So this connection type, it actually tells you over here in this, over here in the side of once you bring in this connection, whether or not you're using a TCP IP, a UDP, or these other things. So this is going to be not that one, this one. Going to be 11, which hex B is already 11. So default on it is good. For this one, we're not going to use this connection block, but if you wanted to swap this server between different blocks, you could absolutely change these parameters and just change between the different connections. So it would be annoying, but yeah. So the last thing on this active establishment is this goes back to kind of into that TCON block, whether or not the TCON is going out to look for a connection or if it is sitting there waiting for a connection. For the server, you're going to want to sit back and have that set to false, and because it's going to sit back and wait and do nothing, and not do nothing. It's going to sit and wait for some other client to come in and connect to it. And so let's look at the way that I actually have this one configured. This is the one that is actually running. And you can see that I have that connection ID, which is the S7 connection. I have that set to 1. That can be different. The connection type is 11. That's always going to be 11. And active establishment is going to be false because you want a client to come in and connect to you. That I say always. There might be some case that you want to go out, but like it's probably 99% of the time going to be false for the server. The client is 100% of the time going to be active. So the server, which we're working with now, is going to be false. So if we go and the remote address, remember this is the server. So let's go online and look at what it is. The server says remote address, and I have all zeros here because this is being set up to where it will allow a connection from any IP address. And this is a first come, first served type of connection. So whoever connects to it first, they get the connection and it locks this connection out. So Siemens only allows one connection per instance of this server block because of this right here. Now, from a secure way, if you didn't want to risk, so there is a type of attack that a man-in-the-middle attack that could be configured in this type of thing on a startup. So if you have two different systems that have two different startup times, you could have a bad actor sitting in the middle, and it could insert itself into the in the middle between your connection. And the only way that it would be able to do this would if you have this set as 0 and it says, okay, I'm going to come in and hijack that connection before the client comes online. Well, a way that you might be able to reduce the likelihood of that happening would be if you actually set the IP address of this device. And so it just makes it a little bit more difficult. So you say, hey, I'm only going to accept an IP address from this one device. Now, you still might be able to have that man in the middle of attack because odds are if that attack, it's going to have to be on the network. And so they probably would be able to say, hey, I know the IP address of what's supposed to be connecting here, and so I'm going to use that IP address. But if you only want to allow a connection to one device or from one device, then this is where it is. And so you would put that IP address in here. I have it set up to where I'll accept from anything, because I want to make it a little bit easier. And again, I've said my remote port, we've talked about that. It can come from any port. It doesn't really matter out there. It only matters that it's coming in to port 502, because that is the ModBus server port. It is 502, so you have to come across 502. So that is the configuration, and that is the setup for the server. And so we'll be playing with this a little bit here in a second. So I'll leave this here. So yeah, Stuxnet. We're sophisticated here for Drives people. If nobody knows what Stuxnet is, like if you've never heard of Stuxnet, look it up. It is the craziest thing, and it has everything to do with Siemens hardware. But it's also, there's some stories about Stuxnet. So yeah, maybe that's if we have time later. You're trying to get me distracted, chat. I don't get distracted. I'm focused. We're talking about ModBus, not about CIA espionage and destruction of centrifuges in Iran. No, we're not talking about that right now. So let's move over to the client side before I get way off topic. Yeah, sure, we can download this. It's not doing anything. And let's look at this block real quick, and I'll show you a little bit of the status before we get onto the client. I do want to show you. Let's turn the glasses on. Let's monitor this block. Let's see if it is ready to go. One thing that you will need to do is this status on your server needs to be hex 7006. And that is sitting and waiting for a connection. That's good to go, waiting for a connection. That's what. If you disconnect this, it should go to 7,000. Yeah. So we've got a 7,000 status there. That means that it's deactivated. When it is booting up and connecting, you're going to get, I believe, a 7,002. I may be wrong on that, but yeah, 7006 sits good to go, waiting for a connection. Now let's go over to our client block. So again, this is on a 1211 CPU sitting back there behind me. Let's go online with it. And yeah, when a reminder, the server block 100% runs on the 1200. So one thing that you could do is if you have a little 1200 processor that you're not stretching the processing power on it, throw a ModBus block on it. What's it going to hurt? That way your Allen Bradley PLC in the plant has a way to be able to connect up to it and communicate to it, right? So just a thought. That's how you can use that. Just at Alpha, we have a couple of different devices that we use in agriculture that we will put out there that are kind of like data acquisition blocks. We're doing some stuff with the data. Maybe we're monitoring some bin. We're doing something, but I'll put a ModBus server on it and just kind of have like, all right, here's some data. You can use that. So one thing I'll show on the client, the server block on the server side, I have it running. I have it running in main, so OB1. So it's just kind of going as fast as it can, whatever. You can do that in on the client side, but I personally wouldn't recommend it. I personally like to control when these sorts of polling and data is coming across, just to be able to kind of limit and control the network. Because if you start just hammering away on, say, 5 or 6 different clients on your network, trying to get this communication going back and forth, you can run into problem. And what is it benefiting you? Oh, you're updating your level for a tank that takes 20 minutes to fill up every 10 milliseconds instead of every 100 milliseconds. Like, you're not really getting anything. So On my client, I have set this up not in OB1. My OB1 is blank. I have set it up in a cyclic data block, for which is set up for 100 milliseconds. Which for this, that seems reasonable because I've got a level sensor back there that we're going to be playing with. So Ignatius asks, what protocol does Ignition use? It actually uses puts and gets. So that is one of the kind of like catching points with the communication with Ignition is it is using puts and gets. So that is why if you're using Ignition, you have to go through and manually turn on this little block. I'll show it to you real quick here. Click here, properties, click on the block, general, connection mechanisms, blah, 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 down here. Lies, the wrong one. Oh, here it is. Connection mechanism, clicked on the wrong thing. This permit access with put and get, you have to have that on in order to use Ignition. Hey, Hegemerl, don't, shh, it's fine, it's all fine, don't worry. But yeah, so that's how you get it and put it. Maybe that would be a good thing for you to talk about, Hegemerl, on one of your streams is do a rant about puts and gets and unoptimized data blocks. Oh, and look at SIP. Look at SIP communication. Ooh, that's even great. What's up, Arteco? It's good to see you. Good to see you. Arteco is one of our newer members in our Discord. If you didn't know that we've got a Discord server over here, we've got, I don't know, I think we're over 200 members now. Got a bunch of people that help out in all sorts of different topics. Mainly for me, drives topics. But there are a bunch of people that it's not just Siemens topics, but yeah. So check that out. It's in the description below, and free to join, free to use, and yeah, we've got a couple of cool stuff happening in there. But Arteco has been talking about some cool, I think it was a steel mill projects that he was working on. Heavy industry is just so fun. It just makes you feel like you're doing something. But back to this TCP block. Yeah, exactly. Hegemerl, we're gonna get you up to that 3-4 hour mark. My record is like 3.5 hours on my stream. So I'm gonna challenge you. Let's next stream, let's break the 3.5 hour mark. Cheers. But we've got our MB client now. If you notice, we could pull this block in the same way. I've set this up in a cyclic update. If you're not familiar with what a cyclic update is, here's just a quick little thing. Organizational blocks are special. They're purple. And so if you go to a cyclic interrupt, you get the opportunity to set this time value. And what that does is that tells guaranteed how fast that block will update. So I have this one set up for 100 milliseconds. And so it will sit there and has a hardware timer that it will execute this every 100 milliseconds. And you can kind of go through and set this up over and over. Even if your OB1, the actual cycle time is down at like 10 milliseconds, this will only update every 100 milliseconds. So it's a good way to balance out the load of your processor and of your communication as well. So that's where you do that. So new block, organizational block, cyclic interrupt. Name your block something really, really well, not the default name. This is not the default. Because y'all know better. Don't name your blocks. Don't leave default names in there. And even here, see, I definitely, this is not the the default name of this block. Don't notice that. Hush. So what we have in the MB client block, it should look kind of familiar. We've got this disconnect. We should intuitively know what that is. If you want to disconnect this client from its from the server, then you have to make this high. So, and I'm not talking about that type of high, chat. Like we're professionals here. Don't think about that. I'm talking about a 0 or a 1, active, inactive. Come on, gosh, why would you even go there? So yeah, if we make this, so you could see this is like communicating, done, busy, it's doing its thing, it's rocking along. If we make this high, all of a sudden it goes to that status 7000, waiting to connect. So it's just sitting there, no problem, waiting to connect. And if we turn that back off, then it goes through the process and starts connecting and starts going, having fun. Now, one thing I will also notice is if we turn this off, which is the request bit, then we get that 7004 down here on our status. So 7004 is the connected, but not anything going. So it's like kind of the ready. The way this block works is every time that you click or you activate the request input, it will pull a request and it will pull this data. And one of the reasons why setting these up into a cyclic data block is good is because I don't have to worry about timing on this request. I just turn it on. I know that this block is only ever going to be executed. This block is only ever going to see that request input being high every 100 milliseconds. So I can just say, all right, turn on and let it do its thing. It's only going to be updated every 100 milliseconds. So again, another way for, another reason why you might want to use a cyclic interrupt block. My music stopped. Can't have that, chat. My music, my heavy EDM. Okay, there we go. It's back. Whew. I gotta have that techno music, otherwise my brain doesn't work. So the rest of them that are familiar to us on this block, should the bottom connect, is going to be the same thing. So let's open up our ModBus Client DB. So it's going to look pretty similar. You're going to have that TCON IPv4 data, same stuff, but let's look at what these are. So again, it just so happens that the first Profinet interface, like on a device, is going to be that 64. So that 64 value, if you're using, is going to be the same. But remember, that is, if you have a different communication card, if you have a different network interface card, that might be different. And you can always use that local -Profinet interface name, right? The ID is that, sorry, Arteco, you got me off. I never realized that yes, that may be what it is. That I was lulled to sleep by too many drives when I was a child, and that's why I like EDM, is because it sounds like a drive running. Yes, only an improperly tuned drive. If your gains are set too high, you're right up there with like dead mouse. Distraction. Y'all are distracting me. So we've got kind of the same connections, and we talked about this before. That ID here, yes, it just so happens to be 1, but if you notice on this device and networks, there is not a connection between these two PLCs. That means that technically those PLCs don't know about each other, And so what they will show up as in these devices is an open user communication. And yes, these local IDs are the same. That does not necessarily mean that they will always be the same. And I know that sounds stupid, but they might not always be the same because those are the local ID. And what is local for the 1500 is not always local for the 1200. Those connections could be kind of pointing in different directions. That PLC, that 1500 might have 10 of these connections, and the client, the 1200, only has one. And so you may run into a situation where that PLC client or that the client connection is not the same as a the 1500. So just so you know. Yeah, so Ignatius, if someone's hacking my brain with they're in trouble. Shame, like, good luck to them. uh, it's a trap. Anyway, so let's go back to this. So our client connection, just know that it just so happens to be that those IDs, those connection IDs, are the same. So if you have multiple of these connecting into one PLC, that's not going to be the same. So again, the remote port now, remember, we're looking at it from the client side. We're looking at it from the 1200 side. So the remote port off over there is the server, and that's 502 because that's Modbus. It's always 502. So that's why the Modbus port is 502. That's a Modbus standard. The local port, we don't care. Just use whatever. We don't care. And so that's why the 0 is there. Now, I talked about this before. This active established, the client is going to reach out and say, hey, server, I want your data. It's initiating the contact. It is on Bumble, and it is the initiator of the communication. If you're not familiar with modern dating apps, good, because you don't want to be. But our client is going out and initiating the communication with our server. And so that is why the active establishment is there. It's starting the communication. It is actively establishing it. Then I have created the same area here in this client data block that we're going to point to for our data. It does not have to be this way. Now, remember, I can go through and I can set up this as a real, I can set up this as an int, I can set up this as just a word, an unsigned int, whatever. Those are just how we interpret the data that is in those locations. Well, if it can cause a lot of confusion if you don't know what you're doing, but for this sort of stuff, just know I've set it up exactly the same so that we can see some of the changes when we start playing them around with it in a little bit. I've got about probably 30 more minutes, and then I want to talk about one little drive thing, and then I got to get off. Otherwise, I'm going to have a lot of people mad at me. So I got to focus, chat. We're going to focus. We're going to knock this out. All right, so ModBus data, that's the same. Let's go through and let's go back and look at this block. The last couple of things are these I'm pointing to the connect parameter, which I kind of didn't talk about before. If I want to point to something in TIA portal, yeah, you can type in this direct address, or you can just go here in this in the details view. If you don't see this, it's there, I promise you. If it's not there, then I think it's here, and then details view. It might not be there. So like, okay. But click on your data block, go to your first point, and then drag it over and drop it. Did I point that to the right place? But that's going to be how you do that. Why did that not? Anyway, I don't know why that was a different address, but oh, never mind. It wasn't. I'm weird. But anyway, that's all you do. You just drag it, drop it, and it creates the pointer. You know it's a pointer because it's got a P. But yeah, I have music in my ears. That's why. Which, by the way, I would give y'all music, but it messes up the Google automatic translation. My redneck accent already gives it enough trouble. It can't do that over dubstep. So the last couple things that we're talking about this block is the ModBus mode, the ModBus data address, and the ModBus data length. So ModBus mode, 0 is read, 1 is write. Real simple, real easy to, like, if you want to read data, you have a 0 there, and hold on, let me one thing, because I think, do I have that pulled up? Section 4.3 gives the div. So, by the way, I've got this document back here that you can kind of see right there that I'm referencing, but that is, the name of that document is ModBusTCP with MB Client and MB Server. Here, let me throw this in the ID so that you can, let me throw this in a chat. That entity ID that's in chat right now is, if you go to the Siemens support website and just search for that number, it will bring up the page with this document that I'm referencing back here. And ModBus has a couple of different modes, and they basically have to do with whether you're reading or writing and where you are reading and writing from. And it's a ModBus thing, that's not a Siemens thing. Just know that the 0 and 1 are kind of the default things. 0 is going to be reading and 1 is going to be writing. And the reason why I say that you want to kind of consider those the default is because from what I have seen, most ModBus registers start at the number 40,000. I don't know why. Maybe somebody in chat can explain why it's 40,000, but you can access lower number registers, but you have to use a 10 something mode, 103 and 116 if you want to access numbers that are lower. With our ModBus server, the way that it is set up, it starts at 40,000. So because this client is accessing a Siemens MB server block, that is going to start at 40,000. And so we're going to read 40 from 40,000, and the first register starts at 40,001. So the first register is 1, which in Siemens world, that feels weird because the first number is 0. So why is it not 40? Anyway, the first register starts at 1 plus 40,000. So that's what this data address is. The data length is every time that you pull this client, every time that you activate this client, then, or you request this client, I should say, it is going to pull this number of words. Okay, so right now it is connected, and you can see it's chugging right along. Click, 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 click. It's going, and it's 7,000. By the way, if you see 7,000 numbers, nothing's wrong. If you see 8,000 numbers, there's a problem. And so 8,000 is going to be some sort of fault. It's not communicating. Something's not working properly. If you're seeing 7,000s here, you're good. Also, if you ever see an 8,000 error, this error is going to be true. So it's going to tell you that it's got an error. So one of the things that I do want to say, when you first set this up, okay, you have to disconnect the 1500 side, reconnect, disconnect, reconnect. So it has to completely start up, and this client block has to be disconnected as well. So disconnect, reconnect. So the first time you download everything's going to be kind of like all over the place. You disconnect, reconnect. So disconnect on, disconnect off, meaning disconnect it's working, and then disconnect on, it's off, and then disconnect off, it's running. And then that should link everything up. If you have done that and you have a 7006 on your server and you are getting some sort of like 8,000, I think it was I was getting like a 80C8 or 80CB. And remember, those are hex numbers. So that's 80CB hex. That means that something is not configured correctly. And what I had actually done, what that was for me when I was setting this up, was I was pointing to the wrong network interface card. And so the client was saying, hey, I'm not getting a response from the server. And it's because it was going through that Profinet 1, and sure, it could communicate, but the block inside the PLC wasn't accepting connections over that network interface. So it was coming in here, and the ModBus server was connected here. And so I swapped that over, reset, blink, and then everything starts working. So just know that if you're getting that 80CB or 80C something, then it's most likely going to be issues on that network path configuration. So let's get into this for 10 more minutes so we can talk about drives. Because I really want to talk about drives. Nah, I'm joking, but we do have 10 minutes. So the ModBus data. So let's talk about this. So right now, this is live data, okay? And this is on the ModBus Client side. So what I'm going to do is go back and forth, and so ModBus is kind of going back and forth with it's communicating. Everything's going well, but we have zeros here. Well, it's because over here in our ModBus data, let's just go in and add in some data here. And I'm going to show you something. I'm going to highlight a couple of different things. That is not a valid integer. There's a point. So now I come back over here. We have data, right? And you're like, wait a second, where's all of our data? Well, we said we only want to pull 4 words, right? We only want to pull 4 words, but we have 6. So let's just change this to 6 and download and see if it breaks everything. Yeah, don't worry. If it's one of my special useless talents of being able to memorize hex numbers. And so now we're pulling across 6 words and doing that. But really the only reason that I remember those numbers is because that was only 2 days ago. Actually, I can't remember what I ate for lunch 2 days ago, so maybe that is something weird. So yeah, we've got logical controls. I haven't paid a explanation on the registers. So logical controls has said, I'm going to bring this out in the chat if you can't see it. So logical controls said that input bit data are 10,001 through 20,000. Coils bit data are 20,001 through 30,000. Input registers are 30,000 to 40,000. And holding registers, most common, word data are 40,001 plus. So that makes sense. So I guess it's these assignments specifically for these types of devices. And so it's kind of in the definition of Modbus, of what these numbers are. So that's awesome. Thank you, Logical Controls. Check him out on TikTok. He's got a YouTube. Show him some love. If you're in chat right now, right click on Logical Controls and say go to channel and click subscribe. Do it right now, because he's got some good content over there. Also, we've got, so you can see here that I'm now updating on my client side 6 words of data. And you say, okay, well, that's cool. That works. Well, what if we did, I want to go back and do something on the server side. And again, one of the great things about TIA Portal is you can be connected up to multiple PLCs in one project and one screen and be going back and forth. And so I've literally just jumped over to my 1500 PLC code and have been and going to make a change. So if you were here in the Heart live stream, so I guess it wasn't last live stream. We did some motion last live stream, but the one before that, we were talking about HART commands, H-A-R-T, which is some cool stuff. If you have no idea what I'm talking about, go back and watch that stream. It's a pretty cool stream. It's pretty cool technology. But we have a block that we made on that stream that parses out HART data. And I have got a Vega Pulse 21 or something like that sitting back there, and I have some real live stream data coming through. And I think this is distance in inches. And so it's reading like 27, yeah, that's about right. 27 inches, because it's like shooting back behind. Oh, you can't see it. It's in this area right here of my shop. But it's shooting a distance of measuring about 27, 28 inches. Okay. So what I want to do is plug that data into those holding registers. So this would be like I'm setting up a ModBus server in order to actually give data out to the world. Okay. And again, if you're not familiar with how inputs and output works on function blocks, this function block we made on stream. Like this is a totally custom, we just made it a function block. And so what we're gonna do is I want to make that data available over in my ModBus register. So here's how I do it. It's super hard. So ModBus Client, don't do that. I almost made a mistake. So I am go into my ModBus data, my ModBus registers. If I want those there, I just drag and drop over into here. And for all of you Step 7 classic programmers, oh gosh, people are actually doing real work behind me. Sorry. So we have these numbers. If you notice something, what happened when we did this, it went from real and all of a sudden we lost our decimals. Y'all notice that? That's because my ModBus registers, that's loud, isn't it? Can y'all hear me? So the ModBus registers are integers, but my output are real. And so it does an implicit conversion between the real of the output of this block into the ModBus register. So I lose those decimal points, but you still see I'm getting 28 inches here, okay? That's cool. So I just did and downloaded that, made that change, and now I should be able to go over to my ModBus client and we see those changes already available. It's already there, and we can see that updating. Yeah, Hagamroll. So I'm in a shared warehouse space, and so people are doing real work behind me, and yeah, so that's what the sound is. That's what I'm commenting on. As long as y'all can hear me, that's all that matters. So that's one thing that we were. That's how you connect those in. You just you can either also say, for example, if I want to go back into, this is my main OB1 in my 1500, say I want to take and so I have a value here. Say I want to move this raw count test level. This is a custom block that I use that's alpha, that just takes in a analog level, converts it to percent, and then controls, if you have a bin that you're filling up, it gives you some outputs and say, hey, my bin's too full. It gives you some set points, and you can do some cool stuff with this. That's what this is. Again, if you're a member and you're at the programming level, you'll get it and you can see what's in there. It's nothing real special, but it's pretty cool. But what if we wanted to take this test level, so our sensor, and throw the raw counts into a value? How would we do that? Well, we threw those values onto an output here. We know how to do that. But let's just take and throw this, and let's just put in a block and then say move, and Control C. Let's just move that level into this 5th ModBus register. Okay? And so this is how you could just move that data from one point to another, because you need to transfer that from an input, you need to transfer it into that ModBus register. And so let's go back to our client, and there you go. The counts are being updated now. Pretty cool, right? Well, let's go through and let's kind of flip this a little bit. What if I wanted to change this ModBus register here, this 598? What if I wanted to change it from the client? Okay, I'll show you how to do that. And this is probably the last thing that we do before we kind of talk a little bit for a few minutes about drives or something. So we talked about the mode, the ModBus mode. We say, all right, if we change this to a 1, that is right. So what we would be doing at that point would be taking from our client block, not this, I'm not using tags, which, yes, technically you could make one of these in global memory, but oh my goodness, your PLC better crash. Like if you use marker memory for this, just the thoughts. So what we would be doing at that point is taking from this ModBus client block and moving it over to the server block. So let's take a pause back and let's say I want to move these. Okay, let's do this. So we're going to show you, kind of demonstrate a couple of different points for this, because you could really jack a process up if you're not working right. Because what I want to do is I want to move those 4 words into the last 4 words of my block over on the other side, right? Okay. So how do we do that? We can go and on our ModBus block, we say, okay, let's stop monitoring this. We want to change this to, ModBus 1 because we want to write. All right. Well, we want 4 words, but what address do we need to start at? Remember, we're not programming in Python. We're not programming in C#. We are programming on a machine that could be operating something. Gosh, that was like maxing up my mic. We could be operating something on a machine that is controlling something really heavy duty and really, really large. Hold on, my mic is just way, the levels on it are off. And so us making this change is going to be overriding on that 1500 PLC. And we may or may not know how that thing's programmed. So this should throw up a flag in your mind of, if I don't do this right, I could throw a car across the room. Or I could overspeed a motor that is kind of like y'all were talking about on a steel mill line. That's a 1,000 horsepower motor. So need to take a pause and say, all right, where do I want to write this data? Because you might be able to think, I'm just going to go ahead and download this, and you might be able to expect, all right, what's going to happen? Because I'm writing this at that 40,001. So it's taking this 40,001, right? But it's taking this block and writing it into 40,001 here. So now all of a sudden I have these 4 words that are kind of getting overwritten. You can't really see it right now because of the nature of the way that I tied everything together, but you can't even see that they're getting overwritten. But you notice, all right, these down here are not being written to. So you're like, okay, this didn't cause a problem for us because of the way that things were being written. But this type of mistake could very much cause a big problem in your process if the program on the 1500 PLC isn't written correctly. And you may not even notice it at first. So just be very careful when you're writing things over Modbus. Because what this is actually doing is taking these first 4 bits, or these first 4 words, and writing it into the 40,001. Awesome. So one of the things we got a guy in chat like talking about a project that they were in. We have a great community here, especially over in the Discord channel. I'm going to plug it a little bit. Check in the description. If you use Discord, we've got a lot of people that help each other out. If you've got questions about a problem that you got, we've got a help desk. If you want to talk about some sort of project, we've got a place to talk about that. If you want to talk about video games and stuff and like controllers and things like that, we got a place for that too. But so what we actually want to do on this client block now is we want to point to start here. So our Modbus data, we want to start our 4 words here. So the way that we do that is change our pointer, because remember, now we're writing. So where do we start? Remember, the pointer says start here. So we want to start 1, 2, 3, 4. We want to start there, okay? And over on our Modbus side, if we look at our server side, we're down, so that's 1, so everything's shifted off. So this is 40,000, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we want to put that into 40,013. So let's do that. So we want to have our address as 40,013. Let's see if this works. I didn't actually test this, so if this doesn't work, I will, yeah, it'll show my PLC inexperience. But this is dealing with pointers. So now let's go back, and hopefully this data is still not there. So what do we got? What do we have? What is our issue here that we've got going? We have an error. So let's disconnect and reconnect. Still got that error. Disconnect. Come on, stop requesting. Stop requesting. Client. Disconnect. Reconnect. All right, so it connected to it. So probably what we've got is, yeah, so this 8383, I don't think I have the, so let's look and see what 8383 is. That's probably going to be a ModBus. So a ModBus problem. So let's look at the status. 8383. Error reading or writing access, data pointer. Data or access outside the address area of data pointer. So maybe we can't do what we're trying to do. So just kind of to illustrate this point though, because I think this is a pointer problem. I would have to dig through on that. What I'll do, is I'm just going to shift this, and that should shift everything down. And let's see if that does that. Okay, so what we have now is this should have everything shifted down. So you see what I did there. Something was wrong with the way that I referenced that pointer. It didn't like it. I would have to dig into what it is. I'll probably make a short about it. But you can see that those registers are on the server side. So that ModBus parameter 13 or 40,013 is going to be here in the register. And so you could probably see as these are changing, they should be updating. It's just not getting updated never mind, it's not updating because they're not reading anything in order to update it. It's just sent that over. So the next thing that we could do is to toggle these back and forth. One cycle every 50 milliseconds, we want a cycle of read, and then every second time to come in, you would want a cycle of write. And all you would have to do in order to get this circling back and forth would be to toggle this MB mode. So this MB mode, you would do 1, 0, pull in everything, and then go to 1. So MB mode 0 is read everything in, and then MB mode 1 would be write everything out. And you would have to update these memory areas. And honestly, that is part of the problem with pointers, is because you absolutely are completely free to screw stuff up. So if you point to a wrong area, you saw where I was pointing, it looked like I was pointing to the wrong place for something, and it just wouldn't let me do it. Like I don't know why it wouldn't let me point to this location, and it was giving me some sort of fault. Like I don't know quite why. Most of the time what will happen is it won't tell you that fault. You take some random value from some random memory location and then shove it into some place that you have no idea what it's actually doing, and then the program just runs it. So that's the dangers of working with pointers, is the fact that you get the freedom to kind of take blocks of data and move them into different areas, and you don't have to know logical control. Talk about, it's crazy how difficult Siemens makes this. it the it's what so to that point, and so we have our blocks running, and so I'm gonna kind of like go into the like free time and just kind of talk because wind down because I've got a call in 10 minutes I got to be on, so um, I'm gonna go here. One of the things about Siemens as we kind of talk about it is yes, especially, and this is like this isn't knocking on any vendors, manufacturers, but here in the U.S., Allen Bradley is king, and uh, the reason why Allen Bradley got such a market share in the U.S. was because they came up with ladder logic back in the 80s, and you didn't have to be a an embedded programmer to program a PLC. And that was amazing. It brought so much access into the world of automation because you didn't have to really understand how computers worked in order to to make a system work, because before then everything was relay logic and it was all literal relays turning on and off like starters and motors and enabling disabling things. It was all literal physical mechanical relays. Logical Controls has a great discussion on one of his shorts about what the difference between a regular relay and like a safety relay is. Before PLCs, it was all relays. uh, and so Allen Bradley took that and said, all right, we're going to make it easy to access. The problem is there's some things that are much more difficult to do with that ease of access. There's some projects that you just can't do because like you have to get down into the embedded systems world. Well, Siemens from day one has taken the other approach. They said our system, our processors are going to be able to do whatever is out there. There will not be a system that you cannot control with a Siemens processor. And so in order to do that, sometimes you got to sacrifice the ease of use and the ease of the ability. And you end up being more of an embedded system programmer than a relay logic programmer. That's where this complexity comes from. So don't like, it's kind of like from that base things. 90% of applications, especially in TIA Portal, are arguably easier to do in TIA Portal, especially if you were using Siemens hardware. If you're using Profinet devices and Siemens hardware, oh my goodness, it is so much easier. But yeah, so that's where that comes from. So I got a quick question. Yeah, and so logical controls. If you're inside of Siemens, there are much better ways. There are ways to literally take the IO from one processor and use what's called iDevice and just kind of copy that data over onto another processor. And it just automatically does it for you. You just check a box and say iDevice, and all of a sudden you have access to that other processor's IO. And yeah, so it's a lot easier. So Larry's got a question, and I've got 5 minutes. Do I ever utilize transfer functions to model your custom systems and finding their stability? So that is a question about drives. And honestly, no. It sounds like from a control standpoint, a transfer function is a response to a system, and those sorts of like systems are really only used if you were designing from scratch a control system for something like the rudder on an AIM-9 Sidewinder missile. If you're using an automation system to control something, if you're using a drive, all of that is already done. And so basically what you are trying to do is in tuning a system is in a real system, you're not going to be able to get a transfer function that's close enough anyway from your calculation that like you're even going to be able to really do anything with. And so it's like, um, so it's like you, if you're, I have, I have looked up some transfer functions before on some systems, and I've calculated them using starter. So like doing the transfer function in Bodie plots inside of starter using the trace function, because they were a very specific type of spring type system. It was a gate to where it was popping up. Um, it's crazy that it was a military application, but it was popping up, and the gate would pop up really fast, and it would go like boom, like that. And I needed to calculate that spring so that I could inject a counter torque at that frequency in order to make it boop, pop up like that. That is such a like highly specific application that you're probably never going to run across one of those in actual industry. But so yeah, there is that stuff there inside of starter transfer functions, but a lot of that is on academics and kind of understanding. I wish it was a gate for an ICBM, but it was gates for military facilities. But yeah, the yeah, that those sorts of things are used a lot more in research and development, and kind of understanding about harmonic frequencies and resonant frequencies of devices, and kind of understanding control theory. Because I kind of mentioned that aim sidewinder, that rudder control on that aim. If you have a spring like in your system, and so that little oscillation going at Mach 3 will disintegrate the missile. And so those are the types of things where you actually need that tight of a level of like calculation of your resonance. But yeah, so that's that question. I've got to go today though. Like I've got people are going to be upset if I'm not on this other call in 5 minutes. But chat, y'all have been great today. Y'all have been great. We have some of the greats. Not some of the. Come on, like Hegermerl is the GOAT. We've got logical controls in here. We've got some of my greats. Ignatius is my general from my African general, and he has been on here from day one, like spreading the good news of Siemens. And yeah, so it's great to see this community growing. It is great to see kind of everybody kind of getting together. The more that we can get together, the more that we can kind of work together, like in the Discord server, help each other out. We're going to be able to help our communities out. This is an international community. Like I said, Ignatius is from Africa. I've got a lot of people from India. I've got a lot of people from Europe, all across Europe, South America, and of course the USA. And I think Logical Control's out of the UK. And so like we've got all of these people that are working together in order to learn and to make our communities even better. And so like keep going, keep learning. It's been a great time, and it's been great to see everybody in it. And yeah, the next one, which I'm gonna pitch. Look past all of that stuff, but do y'all see what's here? Y'all see this? Y'all see this? Y'all see it? Because that's a Delta picker, and I've got all the other parts that I've got printed out for it. So eventually, once I get the cables and everything for it, we're going to be doing that on stream, and we're going to be working with kinematics. We're going to be doing all that stuff. So we've got some cool stuff coming up, and the reason why this is getting out to so many different people is because of all of you that have been liking, subscribing these videos in chat, just everything. I appreciate y'all so much. I've got to get out of here though. Like, and I mean, come on, y'all. It's Friday, and most of y'all are like in Germany. Don't y'all like go watch a movie or something, or something? So like, have fun. Y'all have fun on weekends, and yeah, we're the weird group. Like we're weird. The drives guys are weird, but y'all take it easy. Y'all have a great weekend. Y'all keep learning, but y'all have some fun. Be safe whatever you're doing. Stay warm if you're in the northern hemisphere. Stay cool if you're in the southern hemisphere. Kind of jealous of you right now, it being summer down there. But yeah, y'all take it easy and yeah, have a great weekend. I'll see you next time.